Right, we are starting our discussion right now, focusing on these particular quadratic sequences and series. The general term of a quadratic sequence is t subscript n, which is an squared plus bn plus c, but where a is not equal to 0. Given the quadratic number pattern minus 3, 6, 27, 60, determine the general term of the pattern in the form t sub n equals an squared plus bn plus c. Calculate the value of the 50th term of the pattern. So let's start by looking at these particular questions. So we shall first look at the question 1.1. We need to first determine the general term of the pattern in that form. So we have minus 3, 6, 27, and 60. Let's get started. Right, so we are looking at the solution to 1.1. And we agree that we have the numbers, the terms, minus 3, 6, 27, and 60. Right, so what we do then, we do the following. We find the first differences. Right, finding the first differences means the following. Right, so 6 minus into minus 3 is a 9. 27 minus 6 is what? Right, so we do 27 minus 6. We get 21. 60 minus 27, we get 33. And we do this. 21 minus 9 is 12. 33 minus 21 is 12. So that in the end, then you have 2a equals this. And then here we write 3a plus b equals this. And at the top, we write a plus b plus c equals the minus 3. Right, so a plus b plus c equals minus 3. So the meaning then is therefore that if you have 2a equals 12, you divide both left and right by what? By 2, and it means that a equals 6. So which means therefore you have that in 1.1, a equals 6. Moreover, we have the other equation, 3a plus b. 3a plus b equals 9. A is 6 plus b equals 9. So we substitute the a equals 6 there, and we're able to find that b is equal to 9 minus 3 by 6 is 18, and 9 minus 18 is minus 9. The next thing we're going to do is a plus b plus c equals the first term, minus 3, like so. So a is 6, b is minus 9, and c is minus 3. And therefore, 6 minus 9 is what? It's minus 3, and you bring minus 3 across, and that is going to make c equal to 0. Okay, and the observation in 1.1 is that hence we have that our a is equal to 6. Our b is equal to minus 9, and our c is equal to what? 0. Making t sub n equals an squared plus bn plus c, which means that t sub n equals a, which is what? 6n squared minus 9n plus 0. So, and obviously we had to find the general term, and this is the answer. And this here is the general term, and we have found the results. Okay, so the couple of things that we shall continue to do to solve the next question. So we actually went on to determine the general term of the pattern in the form t sub n equals an squared plus bn plus c. we need to also continue to calculate the value of the 50th term of the pattern. What is the value of the 50th term of the pattern? So to find the 50th term of the pattern, you just find T sub 50, T subscript 50, 1.2. Right, so we are looking at 1.2. From the previous question, we know that T sub n equals 6n squared minus 9 what? N. So that T sub 50 is equal to 6 into 50 squared minus 9 into 50. So that T sub 50 equals, okay, so you do all this here, that's 14,550. 14,550. And that is the answer. 14,550. That is the answer. Okay, so if you use a calculator, you get that answer. Next question. Next question, I'm going to engage you. Yeah, we calculated the value of the 50th term, and the value of the 50th term was just obtained. Now, the next question. Show that the sum of the first differences of this pattern can be given by that. So let's look at that question and see, because we need to show that the sum of the first differences of this pattern can be given by S sub n equals 6n squared plus 3n. So what's the answer? What's the answer to this? Okay, the answer has already been given. You need to show that the sum of the first differences of this pattern can be given by this. Okay, you can see the question, Ayanda. So how do we start? What are we supposed to do? What do you think? You are the only one I'm having now. You'll forgive me because I know that,
Can you please?
yeah, you are the only one, so you must not be afraid of anyone because you don't have other students now. Can you see the question? Are you able to see the 1.3?
Yes, sir. I'm trying to attempt it.
Okay, that's fine. I'm giving you like 2 minutes.
No problem, sir.
Okay, yeah. 2 minutes.
Sir, aren't you gonna do it like I don't know.
Like an
That
example,
one
right?
where we divide by 2, we say Sn is equals to
Yes,
n
yes, yes, it
divided
is
by
that. Okay,
2.
thank you so much. That's what I wanted. That's what I wanted. It's enough.
Mm.
It's enough because that's 1.3. So
Yes,
that's
sir.
what I wanted. Okay, so it's enough because we're talking about the sum, right?
Yes, sir.
So now, because we're speaking about the sum, then we're going to use the formula n over
And
2
2,
into
yes.
2a plus n minus 1 into the common difference d. Are we together? So
Yes.
now, obviously, this is for arithmetic progressions. It's for arithmetic progressions. Right, so now, looking at arithmetic progressions or arithmetic sequences, the couple of things then we need to establish is because we're speaking about the first differences. So the first differences at this point, these are the first differences. Work this out. So at this point, these are the first. These are the first differences. So I'm here to obviously to give more practice problems on this. Even tomorrow we're gonna have another math class. You're just gonna let me know when you're gonna be free tomorrow. So that now we are looking at the first differences. So the first differences now will be this. Now, obviously, if you look at the fact that the difference between the consecutive terms here is 12, that means we are dealing with the first differences. So because the difference is common, it's called the common difference. So this becomes the common difference. So what do we do with the common difference? So let's look at this question, but look at it very, very carefully and apply the skills we've learned in 1.1.3. Right, first things first, what is the pattern? So the pattern is -3, 6, 27, 60, and so on. And then now we are finding the difference here, which is 9, 6 minus into -3, then 27 minus 6. We get a 21. 60 minus 27, we get a 33. Okay, these are the first differences that we've got. But now 21 minus 9 gives us a 12. And 33 minus 21 gives us another 12. Okay, so now, because now we're dealing with the first differences, so these first differences have these. So I want to mention that these are the first differences. So if these are the first differences, we have the following. Okay, so it means therefore this is D. Because for the first differences, this becomes the common difference. And once you have the common difference, then we are dealing with the first term of this, so this becomes A. Right, so you have A, and this becomes the D. Right, so we have therefore that A is 9, we have that D is 12, and then now we look for other things from the pattern. Okay, for example, we have the A and the D, but what is the N? Okay, so the N is kept like that because we are told
The N is
that
not for, right, sir?
the answer must be in terms of N, isn't it?
Yes.
Yes, the answer must be in terms of n, so it means that n is not going to be replaced or by anything, okay? It's not going to be substituted by anything, so which means therefore we'll look at the Sn, which is exactly n over 2 into twice a. Right, what is the first term? The first term is a equals 9 plus n minus 1 into the common difference. What did you get the common
Minus
difference?
12.
We got 12. Well done. Well done, Ayanda. And therefore, this is Sn equals, we just need to simplify this. And once you simplify this, it shall actually become the answer they want here. So which means that just simplify together now. It's going to be n over 2. And this is going to be 18 plus exactly 12n minus 12. So which means that Sn is n over 2 into 18 minus 12 is what? You get exactly a 6 plus 12n, like so, okay? So you divide 6 by 2. If you divide 6 by 2, what do you get? If you divide 6 by 2, you get a 3.
3.
Divide 12 by 2, you get a 6. You multiply it through by n, so you can multiply it through and get 6n squared plus 3n. And hence, the conclusion is therefore that Sn equals 6n squared plus 3n. Like so. Okay, now we have this answer. And now let's check this. So in other words, in 1.3, we say thus Sn is equal to 6n squared plus 3n. Now, let's check the question. Did they say the answer is this? Let's check what the examiner was saying. These are past exam questions we're answering. So we got 6n squared plus 3n, and that is the answer. Okay, so well done. There, we solved it correctly. Using the summation formula, because we have to show that the sum of the first and first differences. We're dealing with n first differences because now we're dealing with the first differences. They form an arithmetic progression. So they form an AP. They form an AP arithmetic progression. 1.4. Okay. How many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21060? How many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of exactly that one there, 21,060? Think about this question and wonder, how do you approach this? How do you approach this question? Where do we start when the examiner is asking us to find out how many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that is a value of that? So, okay, just look at the answer. Okay, this is straightforward because what you're supposed to do is to say, okay, they're asking us how many consecutive first differences were added to the first term of the quadratic number pattern. What is the first term of the quadratic number pattern? This is the quadratic number pattern. It has the terms -3, 6, 27, and 60. So -3 is the first term. And so we are then adding the consecutive first differences. And we're saying how many of these first differences, consecutive first differences were added to the first term. So they were added to the first term. The first term is -3, we saw. So they were added to -3, okay? And if they were added to -3, then the answer will become exactly that, okay? Okay. Yes, Mganam, can I give, yes, Gamba Mganam, can I give you a call when I'm done with my class discussion now? I'm just having a class discussion online. Okay. All right. Yes. So yeah, so is called Nangteta then. Okay. Okay, thanks, Mganam. Okay, we'll talk. Right. So now we are adding the the consecutive first n differences to the first term. So we're adding them to -3 of the quadratic number pattern. To obtain a term in the quadratic number pattern that has a value of these. Okay, so 1.4. Okay. So 1.4 is saying there are terms that were added to the first term of the quadratic number pattern. So obviously, maybe let me just write down something that is very necessary here. The quadratic number pattern. The quadratic number pattern. So the quadratic number pattern is going to be -3. You know it from the beginning. You know it from the beginning. So it's -3, 6, 27, and 60. So we are adding now to the first term. The first term is -3, and we're adding the Sn terms, and we're getting an answer of 21,000 and what? And 60. And we're saying how many of these terms were added. So because of this, then we remember the terms that we added. What is this Sn from our question? So we know what Sn is from our question. Okay, but also we can move the -3 to the other side so that it becomes these plus 3. And therefore, it becomes Sn equals 21, these all together. So now it means that you have 1.4 And the 1.4 gives us Sn equals what? It becomes 21063. It becomes 21063. So now we have 6n squared plus 3n is 21063. So that in the end, what we're then getting is 6n squared plus 3n minus 21063 equals this. Okay, so divide through by 3. 6 divided by 3 is what? Is 2. You divide 3 by 3, you get a what? A 1. So it will just be 1n. And then you divide the 21,063 by 3, you get exactly 7,000 and... Okay. Okay, this one here, we're bringing to the other side, but it's a 3. Right. It's a 3.
720. 7020.
Yes, well done. It will be 7021. Correct.
So
So
isn't it 20?
please come again.
Isn't it 7020?
Yeah, because I missed the 3 before. That is why.
Oh,
Yeah,
I
because
see.
I had written like a 60.
Oh, I
Because
see.
I missed the 3 because the 3, but I accidentally wrote a 0. That is why it
Oh,
was 20 here.
because the 3 went that. Oh, I remember, sir.
Yes, yes, because you went it out when it was 60 and then you got 20 here. Okay,
Yes.
like you got 7020. Okay, that's okay. So let's factorize these. What are the factors of these? So the factors of these are exactly 2n plus 119. As I said, that we can have mathematics every day, but you don't need math as such every day because sometimes you are busy with other things. So you can do the mathematics, but at least once a week. If you are busy that week, at least once a week, you need to have mathematics. Okay, right. So if you factorize these become the factors. And now let's proceed to 1.4. So we've seen therefore that it's 2n plus 119 into n minus 59 into n minus 59, and this becomes 0. Okay, as a consequence, what we're then getting is therefore that n is 59, n is minus 119 out of 2. Okay, so this is the case. But we agree, therefore, that n can't, because it's the number of terms. So this n is negative. So we can't have negative number of terms. And hence, the number of terms would be the positive number of the terms. And therefore, n is only what? It's only
59.
59. And that is the answer to the question, because it was a little bit a worded question that they just said here you have the first term of the quadratic number pattern, and you are adding consecutive first differences, and now we're just adding Sn. Okay, good. Let's look at the next question. Okay, good. Let's look at this one. This one says 7x, y, and minus 11 is an arithmetic sequence. Determine the values of x and y. What do you think about this question, Ayanda? Just something easy. Your thought? I'm giving you 2 minutes to think about it and give the answer, because they want the values of x and y. I'm giving you like 2 minutes, and then you can suggest to me what x and y are. Okay, these are like past exam questions, so they are at exam level. You let me know when you've got the answer.
Yes, sir.
Okay.
So I can't get it.
All right, that's fine. Thank you. Thanks for letting me know. It's okay. The aim is not to torment you, is not to torture you, but the aim is to train you to become a mathematician and to get 100% in the math. We've had our matrix getting full marks in mathematics last year. So I'm expecting you to get full marks. So you need to like join the math discussion most of the time. If you get a chance, I'll always check with you if you're free because I have a couple of other students. But I always remind you like every day so that when you're free, you can join. If you're not at school that day, you join so that you can get 100% in the math. We need full marks, distinctions in math. Okay, now let's look at what we need to do here. Very easy question, number 2. Right, now the question 2 is a very interesting one because the examiner here is giving us the sequence 7. X, y, minus 11, and so on. And they're saying we must get x and y. And they're telling us that this is an AP. So it is an arithmetic what? It is an arithmetic progression.
Mm.
Okay, if it is an arithmetic progression, we must find the values of x and y. So where do we start? Now, there are a couple of things we need to know about an arithmetic progression. What do we need to know about an arithmetic progression? An arithmetic progression has something we call the common difference. And the common difference is just one thing, and it's the only thing that we need to know here. It's not many things like about sequences and series. It's just the concept of the common difference. And with that, then what does the common difference say? We know that the common difference is the second term minus the first term, which equals the third term minus the second term. What is the second term? The second term is x. What is the first term? The first term
F,
is 7,
F,
okay? Then
F of
what is the third one? The third term is y.
Y,
The second one is
X.
x. Okay, good. So this gives us an equation. And once we get this equation, then we proceed with ease. And then we then say, we can group like terms together, etc. For example, we can move this x, that is negative x, to the other side. So negative x moved to the other side becomes plus x, so that it becomes twice x minus 7 equals y. So, but also we have the following. We can do it this way, or we can do it differently. How else can we do it differently? We can, because this is like T1. This is like T2. This is like T3. And this is like what? T4 in the sequence. So it means, therefore, we can also go on to use other differences, like we can say T4 minus T3. We can say T4 minus T3 is equal to T3 minus T2. What is T4? Is minus 11. T3 is Y. T3
Y,
is Y. T2 is X.
X.
Okay, so because you see, the thing is that we need another equation because we have like two unknowns here, X and Y. So we can't be able to solve these and get any answer. So we need another equation to solve them simultaneously. So now at this point, what do we have? For example, we have this, so we can manipulate these equations and to do what we want. Like we can move this y to the other side so that it becomes a plus y, or we can move the terms in any other way. So for example, I mean, we can move this y. If you move this y to this side, it becomes minus minus y. So it gives us minus twice y is minus x. All right, so that's one thing because we just moved this y. It was just y. So here, bringing it across, it became minus. So it's minus minus, right? So if you divide through by negative, because there's a minus x here, let's just divide minus x by negative, it becomes a plus. Or you multiply through by each term by negative. Right, so which means here it's going to be just an x, and this is going to be a 2y, and this is going to be an 11 like this. Okay. And these are equations. So this one is equation 1, and this one is equation what? 2. We proceed. We proceed. Let's look at this one. So we have y equals 2x minus 7, equation 1. Y equals 2x minus 7, it is equation what? 1. And x equals 11 plus 2y. X equals 11 plus 2y, which is equation what? 2. And then we can come here and say, we can solve this simultaneously, put one to the other. For example, we can say put 2 into 1. Right, so wherever there is x is equal to this here. So which means we shall have y equals 2 into, wherever there is x, then we put 11 plus twice y. Right, in the place of x, we put 11 plus twice y minus 7. So this is y equals 22 plus 4y minus 7. So which means now, let's manipulate this. So we have 4y. Okay, you can move the y to the other side. So if you have y minus 4y, what is y minus 4y? It's like minus 3y. And what is 22 minus 7? Like 15. Okay, so if you have this now in number 2, so you have minus 3y equals 15. So we need to solve for y. So we divide by negative 3 like this. And then it means y is minus 5. Good. Okay, when we got that y is minus 5, what is x? X is 11 plus 2y. X is 11 plus twice y, which is 11 plus twice. What is y? Y is minus 5. So we have 11 minus 10. What is 11 minus 10? Is 1, and that is number 2. And hence we have the following. Right, hence we have that x equals what? Right, so x equals 1 and y equals minus 5. X equals 1 and y equals minus 5. So now these are the answers we're getting. And therefore, we're done. This is what we have to do in this question there, Ayanda. Now let's do more questions that look like scary. Okay, let's do like more questions that look scary. There's something we call the sigma notation. Right, let us discuss what we call the sigma notation. Right, what is sigma notation? Right, so sigma notation is the following. Here comes a question. Prove that. Right, prove that the summation, the infinite series from k equals 1 to infinity of 4 times 3 to the 2 minus k is a convergent. You say convergent. Convergent. It's a convergent geometric series. It's a convergent geometric series. And the question is show all your calculations. Show all your calculations. Number 2. Right. Now looking at number 2, we have another question. If this infinite series k equals p 4 times 3 to the power 2 minus k equals 2 over 9, determine the value. All right, so determine the value of p. Right, so now let's look at these problems and we prepare solutions to these. We prepare the solutions to these. Now the first one. Prove that this series is a convergent geometric series. Show all your calculations. Okay, to prove that, how do you prove that it's convergent? That is the first question. How? Where do we start? How do you solve these questions? So now we're looking for a convergent geometric series. Okay, and then in the next case, determine the value of p if the sum is this. Okay, now let us solve this. Very straightforward. Now we have this one first. Now, how do we therefore prove that this is a convergent geometric series? How do we prove the convergence? Right, to prove the convergence, we first write down the question. Number 1. So we have this infinite series from k equals 1, 4 times 3 to the power 2 minus k, which equals 12. Okay, you write out the things, okay? So we need to expand first to prove the convergence. So let's just write a bit more steps here to make sure that this makes more sense. Okay, so when k is 1, you substitute. So this is going to be 4 times 3 to the power 2 minus 1 plus 4 times 3 to the power 2 minus 2. Plus, let's do 3 terms, okay? 4 times 3 to the power 2 minus 3, and so on. So this goes on. So now what is 2 minus 1? 2 minus 1 is 1 there. So this is like 3 to the power 1, which is only 3. So what is 4 times 3? 12. Plus, and therefore here, this is 2 minus 2, which is 0. So this is exactly 4 plus 3 to the power 2 minus 3, which is exactly a minus 1. So this is 4 out of 3, and so on, like this. So what does it mean to us? So we've written out these. So there's something we call the constant ratio. Right, what is the constant ratio? Right, in number 1, the constant ratio means the second term over the first term. But also the constant ratio is the third term over the second term, like this. Okay, so what is the second term? Right, the second term is 12, the second term is 4, the first term is 12. Second term is 4, the first is 12, and the result is 1 out of 3, because 4 goes 3 times into 12. Now let's check the other one. Right, if you look here, we have that the third term is 4 over 3. The third term here is 4 over 3, and the second term is 4. And the answer is 1 over 3 here. So And because of this, we're able to make the following deduction. -1 is less than 1/3, less than 1. So which means that for this ratio lies between -1 and 1. Thus, the series is convergent. Therefore, or thus the series is what? Is convergent. How is it convergent? How? How do we see that? Because
Because
-1 is less than or less than 1. Okay, so it's convergent because of this. Now, there are a couple of other things that you need to sort of master in this case. So let's just continue and analyze the next question. We've proven that it's convergent, but now here is this one. This one says if the infinite series from k equals p to infinity, obviously, 4 by 3 to the power 2 minus k equals 2/9. Determine the value of p. Now, I'm giving you 2 minutes to try this one, Ayande. What do you think?
I'm trying it, sir.
Okay, that's fine. That's okay. I'm giving you like 2 minutes. Okay.
Good evening, sunshine. What is a choreographer?
Please let me know when you're done.
So I can't figure it out.
All right, that's fine. That's okay. You're still learning. You're still learning. Okay, so you're going to practice more. Even tomorrow, we're going to have more math. Okay, now, at the time that you're free, you are not in church, you let me know. It's Sunday, so you're going to... Okay, let's look at these now and see what we need to do. Right, number 2. So we're saying if you have the infinite series equals p 4 by 3 to the power 2 minus k equals 2/9. You determine the value of p. And now I want us to note a couple of things here. So that if k equals p, so let's write out this, the first terms here, because when k equals p, what does it mean here? Right, when k equals p, so you substitute p in the place of k. Okay, so it's going to be 4 times 3 to the power 2 minus p plus 4 times 3 to the power. You start from p, then the next one is p plus 1, and so on. Right, which means therefore we're going to have 2 minus, in the place of k, you're going to have p plus 1. Because we start with p, and then the next one is p plus 1 in the place of k. And then you're going to have the next one, which is p plus 2. Okay, and the pattern continues. And then this is 2/9, like this. So, which means that we're going to have the following. So we're going to have 4 times 3 to the power 2 minus p plus. So it is 4 times 3 to the power. Okay, here it's 1, so it's 2 minus 1, which is 1 minus p. Plus 4 times 3 to the power. Here is minus p, and so on. So this is 2 over 9. So this is 2, like this. Okay, now the couple of things I want us to sort of focus on, it is actually finding the sum to infinity. What is the sum to infinity of these? So what is the, also, I mean, we know the constant or the common ratio, the constant ratio. So what is the first term of this? All right, because to deal with this, this is an infinite series. So the formula for infinite series is that Sn is A divided by 1 minus R, where the constant ratio is smaller than 1. So we need the first term. We need the first term and we need the constant ratio in this formula. So what is the first term? The first term is this one. Is 4 times 3 to the power 2 minus p. So the first term is 4 times 3 to the power 2 minus p. So that is the first term. Then what is the constant ratio? Right, so to get the constant ratio, we need to divide T2 over T1. Okay, so what is the second term? It is this one, 4 by 3 to the power 1 minus p. It is 4 by 3 to the power 1 minus p. 4 by 3, the first term, to the power 2 minus p. 4 cancels. We have 3 to the power this minus this plus this, and therefore it is exactly minus 1. And therefore it is 1 over 3. And so the conclusion, therefore, is that our R is 1/3. Our constant ratio is 1/3. Our first term is exactly this one here, and we have the answer to this. 2, summation to infinity. This. Now, okay, this sum, this sigma, this symbol is called sigma. So sigma means the sum to infinity is 2 over 9. So we come here. The sum to infinity is 2 over 9 equals, what is the first term? Is 4 by 3 to the power 2 minus p. So it's 4 by 3 to the power 2 minus p. 1 minus the constant ratio. Okay, we can choose to multiply by 3 over 3 to eliminate the fraction. So what we have here is exactly 2 over 9, which is exactly 3. So this therefore becomes 3 minus 1. Then you multiply through by 3 in the, okay, this is the 3 in the denominator. 3 by 1 is 3, 3 by 1/3 is 1. So now we have 3, the top 3 multiplies the numerator there. So it is, it's going to be just 3 by, so this 3 has power 1, so you're going to add a 1 there. So it's minus p plus 1, like this. Okay, so now the second thing. So we have that 2 out of 9. Which is 4 times. Okay, 3 to the power 3 minus p. Three minus 1 is what? Is 2. Okay, divide 4 by 2, get a 2. Okay, so at this point, you can just multiply the left by 2 over 9 and multiply the right by 1/2. So now we have number 2. And therefore, these two cancels, giving us 1/9. And then now 2 cancels and giving us 3 to the power 3 minus p. Which means it is 3 to the minus 2 equals 3 to the power 3 minus p. Which means minus 2 is 3 minus p. Right, you can bring the p to the left and then have 3 plus 2, which means that 3 equals 5, and that is the answer. Okay, so p equals 5. Okay, so this is what you obviously you had to do here. I have a lot of questions on the sigma notation, so I'm just going to give you a couple of exercises that you need to try. And these exercises that you need to try are very important, so you try them, and we're gonna discuss them. Also, I'm gonna do more examples. Let me just see. I can just do more examples, just a couple more examples, and then I'm gonna give you an exercise. This exercise that I'm gonna give to you. Um. Okay. So let me see. Just one sec. Okay, I'm just gathering more. Here they are. The too many, the lots and lots. Let's start with this one here. Let's start with this one here. Right, this one is an example. It's an example. If the common ratio is 1/5 and A is 2000, determine determine Tn, the general term of the series. 1.2 T7, 1.3, which term of the series will have a value of 16 divided by 15,625. Solution? Let's look at this solution to this. Right, so the couple of things that are very key here. For example, if the constant ratio is 1/5 and the first term is 2000, determine the general term. Where do we start? What is the answer? Here, I'm giving you like 2 minutes to try 1.1, Ayanda. Please let me know when you're done with it. Please let me know when you're done with it. Just 1.1, not everything. What formula are you going to use in 1.1, Ayanda?
So am I not using the Tn is equals to a squared plus b?
Yes, yeah, your own point. Because this one is heavier.
General.
The one that has the constant ratio means it is geometric. So for the geometric progression, we use this one for GPs. Geometric for geometric progressions. Okay, we use this one because there is R. There is R in the question. Here is R. The R is 1/5. Okay, the R is 1/5, so we use that Tn formula. But now we have the first term is 2000. The first term is 2000, and the constant ratio is 1/5. So we come here. So which means the first term, in the place of A, we put 2000. In the place of R, we put 1/5, and we have n minus 1. That is the answer. Because just substitute. The question is saying determine Tn, the general term of the series. So we need Tn. And therefore, this is Tn. So we use the Tn formula, but we use the Tn formula that has R in it because we're given R is 1 out of 5. So obviously, this Tn equals AR to the power n minus 1 works for GPs, the geometric progressions. And the Tn is this. Now, what is the next question? The next question is we must find T7. Determine T7. How do you think you can find T7? And T7 obviously means the 7th term. How do you think you can find the 7th term here, Ayanda?
So where does n we put 7?
Well done. Excellent. That's a distinction for you. I'm just teasing you with some of these, very obvious. So obviously in 1.2, then you already know from the previous question that we already have Tn, right? Which is 2000 into these to the n minus 1. So now to get T7, what you do is wherever there is n, you actually replace n by what? By 7.
7.
So that you have 2000 into, then you have 1 out of 5. 7 minus 1 is what? Is 6. And then you'll just use a calculator to get the answer to this one.
So it's 0,128.
Yes, it's 0,128. So you can write it as 16 out of 125.
16 over 125.
Yes, like 16 over 1. But yeah, it is equal to that decimal, but it's just that I'll have to check carefully the decimal. But I'm sure that it is 16 out of 125. But yeah, it is some decimal. Points, 0 point something. Okay, good. Which is obviously an equivalent answer. But now this is also the simplified version of the answer. Okay, let's look at the next question, Ayande. Now the next question says, which term of the series will have a value of this? We have already found Tn for the series. We've already found T7 for the series. Which term of the series will have a value of 16 out of 15,625? Where do we start? I mean, how do we solve a question that says which term? What do they want? What are we supposed to look for in this question? Okay. So they're saying which term of the series will have a value of this. They're saying this one is a term. This one is a term. Which term will have the value of this? There is a term that is equal to this. So, which means that in 1.3, In 1.3, there is a term, but we don't know the term, but it is exactly 16 out of 15,625. We don't know what term it is, but the term is equal to this. So now we need to find what term it is. So we are looking for what? We're looking for n. So n is the question mark. Okay. So we don't know what n is. We don't know what term it is. We don't know the term number, or the number of that term. So now, but we know the Tn. What is the Tn for this question? It is 2000 into 1 over 5 to the power n minus 1 is equal to 16 divided by 15,625, like this. Okay, so we just need to proceed to solve this 1.3. 2000 into 1 over 5 to the power n minus 1 equals 16 divided by 15,625. 65, yes, okay. Now, let's solve. You need to divide by 2,000. So if you divide by 2,000 both left and right, so you're going to have 16 divided by 15,625. And on the right, you're going to have 1 out of 2,000. Like this. So now you'll see that at this point, what you have is use a calculator for the right because it's quite messy. Right, so if the right-hand side is very messy, then use a calculator for it. And if you do, this one is 1 out of 5 to the power n minus 1. And now this is, it is going to be 1 out of 5 to the 9th power. Okay, using a calculator. You can just be able to see that. So that 1 out of 5 to the power n minus 1 is 1 out of 5 to the 9th power, which means n minus 1 is 9 and n equals 10. So that's the answer. That's the answer. Okay. Next question. This one, Ayanda, is for you. Consider. Okay, this one is like another question. So it's not, it has nothing to do with the previous things. So it's like another example. Right, in this example, we are looking at consider. Consider the geometric series. Consider the geometric series where n equals 1 equals 27 and S3 is 26. Calculate the value of the constant ratio. Constant ratio R of the series. Okay, of the series. Like I said, this one is for you, Ayanda. Past exam question, what do you think? Right. Right, consider the geometric series. It says that the infinite series is 27, but the sum of the first 3 terms is 26. So it's geometric. It's already a geometric series, this. So it means that we're using the formula that is Tn equals that. AR to the power n minus 1. So I'm giving you like 2 minutes to say, how do you think we start here? Okay. You'll share with me how you think we start here.
So do you find the general term first?
Yeah, well done. We find the general term first, okay? Slightly tricky question. But now, because here you have this sigma from 1 to infinity, it means S infinity is 27. So as part of the solution, because, right, as you're looking for the solution to this, you know that the infinite series of this one from n equals 1 of t sub n equals
27.
27. And what does that mean? Well, this alone means that the sum to infinity, we know very well that it is this, but this sum to infinity equals 27. Okay, so yeah, see that. So this alone, the fact that this sum to infinity equals that means that S infinity is 27. This, the fact that is the infinite series that is 27 means that. Okay, sorry, but we already know that this sum to infinity has its own formula, which is a over 1 minus r. But the examiner did not end there. The examiner went on to say, but you have S3. S3 is 26. What does it mean to say S3 is 26? So the first term of a geometric series is A. The second term is AR. The third term is AR squared. So because we know that Tn is AR to the n minus 1. So to get T1, the first term, you just replace every n by 1. Okay, if you replace the n by 1 here, it becomes 1 minus 1, which is 0. R to the 0 is 1, giving us A. T2 would have 2 minus 1, which is 1. So it's AR. T3 is going to be 3 minus 1, which is 2, which is that. And therefore, this series here equals what? Equals 26. So we have two equations that we've got. What are the two equations? Right, the first equation is A divided by 1 minus R equals 27. And this you can cross multiply here, making A equals 27 into 1 minus R. Next point is to consider this one. Okay, so is to consider this one, which is A plus AR squared. A plus AR squared equals 26, which is A into 1 plus R squared equals 26. We can call this one the second equation. We proceed to put equation 1 into 2. Wherever there is A, you put this here, which is 27 into 1 minus R. 1 plus R squared equals 26. Okay, you multiply this one is like the factorization of a difference of 2 cubes. So if you multiply these, it's going to be like 1 cubed minus R cubed. This, which is 26. You can just multiply out and see that, okay? So now this means you have the following. So that's 27 into 1 minus R cubed is 26. Distribute, you can distribute and have 27 minus 27 R cubed equals 26. Minus 27 R cubed equals 26 minus 27. Minus 27 R cubed. What is 26 minus 27? It's minus 1. So which means that at this point is r cubed, you divide by minus 27. And this gives us r cubed equals 1 over 27, which means that r cubed is 1 out of 3. 27 is like cubed like this. So when the powers are the same, you can equate the bases and therefore say whatever the examiner wants is the constant ratio, and it's 1/3 for this question. Because they were saying that consider the geometric series given by this. The sum of the first 3 terms is 26. Calculate the value of the constant ratio of the series. We need the constant ratio R, and we found that the constant ratio of the series is actually 1/3. Okay, let's continue. Let's continue. Here are some other questions. Next one. This is another example. It is another example. In this example, we're going to do the following and say, for which values of x will the following geometric series converge? A, 1 plus 2x plus 1 plus 2x plus 1 squared. B, 2 minus x, 2 minus x cubed, 2 minus x, excuse, squared here, and then cubed, and so on. Okay, now you have part C, the infinite series. I equals 0. 4 into 3 minus x. Which is to the power I. Solution. Let's look at the solutions to this. Right, so to solve this here, the couple of things we shall consider. For which values of x will the following geometric series converge? Let's look at the first one. Here, we're just gonna do one, and the others will be exercises for you. Right, so that you can have some home activity B and C. I'm gonna upload the video in the next couple of minutes, and I'm gonna send you the link so you can watch the video and take down these things. So let's do a part A. So we have 1 plus 2x plus 1, 2x plus 1 squared, and so on. So we have the constant ratio, which is T2 over T1, which is 2x plus 1 over 1, which is 2x plus 1. Right, for convergence, For convergence, we require that the constant ratio must lie between -1 and 1, which means we have this. Yeah, okay. So it's the the constant ratio is 2x plus 1. So it's 2x plus 1 here. So that part A is less than 2x plus 1, less than 1. So what you do here, you subtract 1 from each of the parts of this inequality. So you subtract 1 here. Uh-huh. -2, 0. Multiply by 1/2. To remove the 2, you multiply by 1/2 across. -1 is less than x, less than that. Less than 0. And that's the answer. Next. So now these ones here will be your home activity, B and C. Okay. Um, let's just do another exercise here. Here comes another exercise. Okay, so this one is about is a question, is an example. So we're making it an example. Okay, in this example, we're focusing on quadratic number patterns. So this one is a quadratic, it's about quadratic number patterns. Consider the quadratic number pattern. Right, consider the quadratic number pattern namely -145, 122, 101, and so on. Okay. Write down the value of T4. So we need the fourth term, 1.2. Show that the general term of these number pattern is T sub n is minus n squared plus 26n minus 170. 1.3 between which two terms of the quadratic number pattern will there be a difference of minus 121 question mark. So we're looking at 1.4. What value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1. Solution. Consider the quadratic number pattern minus 145 minus 122 minus 101. Write down the value of the fourth term, but this one is already a quadratic number pattern. Right, so now we proceed with the solution to this. Right, so we have 1.1. 1.1. Which is minus 145 minus 122 minus 101 and so on. Now here we can get that one. So you can get the difference between these terms here. Let's find the difference here. Goodness me, like this. This minus this is what? That is minus 122 minus into minus 145 is 23. This minus that is going to be 21. And therefore, the difference here is 21 minus 23, which is minus 2. So obviously, because the quadratic pattern, we expect the second difference to be minus 2 all the time. So if you like, say 23 minus 2 is 21. 21 minus 2, you get a what? You get a 19. So once you get a 19, then you realize that the 19, here it is 23 plus this that produces that. 21 plus this produces that. 19 plus this produces a minus 82 here. So which means that in 1.1, the answer is minus 82 because write down the value of T4, the fourth term. So this first, second, third, and the fourth. So which means that the value of the fourth term that they want is minus 82. So we're done with that. Then now we are looking at the next question, 1.2. Show that the general term of this number pattern is this. Right, so the answer to 1.2. Right, so we know that we have minus 145, minus 122, minus 101. 23, 21. Okay, here the difference is minus 21, minus 2, minus 2. Okay, you have a 19 there. We have seen here that we have a minus 82 here. And this pattern continues. A couple of things remain very important. 2a becomes the second common difference. 3a plus b becomes the first term of the first differences. These are the first differences, second differences. A plus b plus c is going to be equal to the first term of the quadratic pattern. So, which means now dealing with quadratic sequences, 1.2. 2a is minus 2. To get a, you take the 2a, you divide by 2. A is minus 1. Okay, then you have 3a plus b is 23. Which means minus 3 plus b is 23. You bring the 3 across to give us 26. Right, so we have b equals 26. Right, so we've taken the 3a plus b equals 23. It came from here. 3a plus b is 23 came from here. We first used the 2a equals minus 2, which 2a equals minus 2 produced the a. Then now we're looking at 1.2. And 1.2 now focuses on a plus b plus c equals minus 145. A plus b plus c equals minus 145. A is minus 1. B is 26. Plus c is this. Which means now 26 minus 1 is 25. So this is that minus 25. And the answer is what? Minus 170. Which means that it is an squared plus bn plus c, which means t sub n equals the a. The a is minus 1, which is minus n squared. The b is 26. Is 26n, and the c is minus 170, and that is the answer. So to write the Tn like that, because then the Tn is minus n squared plus 26 minus 170. You see, that is because the question said you have to show that the general term is minus n squared plus 26n minus 170. We've done that. We've done that. And we've shown these and we've proven. Okay. Next question. Between which two terms of the quadratic number pattern will there be a difference of minus 121? So obviously now we're looking at the first differences there. All right. And now these first differences, so that these first differences yield a minus 121. So that would be 1.3. Right, in 1.3, then you shall have the following. So these first differences, they produce this one, like I said before. So these first differences at this point, what they produce this one becomes the common difference, and this one here becomes the first term. So in 1.3, in 1.3, then just write down that one in detail. So you have the minus 145. You have minus 122. You have minus 101 and so on. Yeah, you can put the minus 82 as well. Right, we got the minus 82 as well on our own. Right, when you get the differences here, we've already seen them. I'm not going to bore you with those. This became 23. These by taking the next minus the previous, and this became minus this. So the first term is this. Right, which means that in 1.3, a minus 1 into d, the first term, 23. So now we continue here. This is 23. You must distribute here, which means is minus 2n minus 2n plus 2, which means it is exactly 25 minus 2n. Okay, 23 plus 2 is 25 minus 2n. But in 1.3, they are saying that this term is minus 120 something. Here's the question. Between which two terms of the quadratic number pattern, yes, will there be a difference of minus 121? So the difference is shown by Tn of the first differences. Right, so in 1.3, then you have that is minus 121. Okay, but you already know that this one is 25 minus 2n. 25 minus 2n equals minus 121, which means you bring a 25 across, which is minus 146. Minus this equals minus 146. You divide by minus 2 like this, which means n is what? N is 73. So n 73 means that this implies between T73 and T74, like this. It means because if you get n equals 73, it means it's between T73 and T74. Because for instance, when the difference is 23, When the difference is what? Is 23 and it is, and you're able to get that this is term number 1. So it becomes between term number 1 and term number 2. This 21 is term number 2. So term number 2 is between what? Is the difference between term number 2 and term number 3. So in the same way, when you're getting 73, it means between T73 and 74. Next question. Next question. What value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1? So you must get the maximum term so that you can know what must be added to it. So what is the maximum term? So to get the maximum term here in 1.4, we use the formula n equals minus b over 2a, and this is for the axis of symmetry. Axis of symmetry of a parabola. Parabola is of the form Tn equals an squared plus bn plus c. Sometimes write it as y equals ax squared plus bx plus c. So this is the parabola we're dealing with. But at this point, you already know that Tn equals what for this question? I know you might be tired already. It's minus n squared plus 26n minus 170. At this point, you can see that a is minus 1 here. B is 26. C is minus 170. Minus b over 2a. Minus 26 over 2a, which is 13. So which means that in 1.4, you'd have Tn equals minus n squared plus 26an minus 170. Okay, by using the n, we got 13. So wherever there is n, you put 13 here. So this is going to be like 13 squared plus 26 into 13 minus 170. And the answer is minus 1. So what can we add to minus 1 to get 2? So we're saying to minus 1, we must add something so that the answer is 2. What can we add? We can just solve for x. We add x so that the answer is 2, and then you move it across, and then x becomes what? 3. And it means that, no, that's not, you need to add, what can you add to get a 1? Okay, here's the question. Okay, you need to get a 1. Yes, formed will be 1. Okay, so in other words, what value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1? So you're adding to the maximum. So which means that, yeah, you modify here. So in other words, you add here so that the result is 1. Then you have 1 plus 1, which is 2. What value must be added so that the result is 2? So this is 1.4. Right, so And this means that you need to add 2. Add 2. Okay, you need to add 2 to minus 1 so that the result is 1. Okay, I think that this is enough for today. Now we're going to chat again on WhatsApp. So you're going to let me know the next time you are free, when you are free tomorrow, and then we can do more. You need to do one math lesson every week, at least, minimally. So you let me know when you're going to be free again. But yeah, tomorrow it will be ideal that we meet. So maybe you're going to be going to church, it's okay. But when you're back from church, you let me know. We're gonna chat on WhatsApp. You're gonna let me know time that like is gonna suit you tomorrow so that we can do more math. These exciting things we've done must not just be a movie. You must take these and write them in a notebook. So you must get a notebook that is not your notes at school. And in the notebook, you note everything down that we've written. You try the 2 exercises I gave there, okay? But I'm going to send you the video link in the next couple of minutes, okay? Thanks, Ayanda. Goodbye to you, Ayanda.
Thank you, sir. Goodbye.
Goodbye, Ayanda.